Good day everyone, my name is Princess Lita Gyong from ESHM 1-1. Today, we discuss all about the process and how to get the value of relative position per group data. What it's all about, how to get its value, and what its complications. Do you know what are the main three measures of quantiles or relative positions? And these are quantiles for 4 equal parts, deciles for 10 equal parts, and percentiles for 10 equal parts.
Now I will going to discuss with you the process on how to get the value of the quartiles for group data. Since we're going to find the value of the first quartile, then the formula that we're going to use is the formula for a group data, and that is n/4. Just want to say that the frequency distribution table is always provided, but in our case, we provide for our own frequency distribution table. So we have an example here. The table represents the scores of 50 students in a chapter test. So the formula that we need to use for computing the quartiles for group data is Q equals L sub QC plus C, close in open parenthesis Q, close in open parenthesis n/4 minus F sub B all over F sub QC, wherein LQC is lower boundary of the quartile class, C is class size, FB is less than or cumulative frequency before the quartile class, N is the total number of observations, and if QC, frequency of the quartile class. So our total frequency is 50 n/4 or 50/4, that is equal to 12.5. So we need to find other less than cumulative frequency or the smallest number that is equal to 12.5 or greater than 12.5. And that is 15. So our quartile class is this. So Q sub 1 equals 15.5 plus 5, close in open parenthesis, 1, close in open parenthesis, 50/4 minus 3 all over 12. 50 divide 4 times 1 minus 3 divide 12, and that is 0.79. Q sub 1 equals 15.5 plus 5 times 0.79, that is 19.45. So our answer is Q sub 1 equals 19.45. Since the quartile class are equally divided into 4 parts and each part has 25%, and since we are finding the value of first quartile, we say that 25% of the students get scores equal or above 19.45, or 75% of the students get scores equal or above 19.45. After we get the value of quartiles, we need to check if the value that we get is somewhere in between quartile class. The class interval of our quartile class is 16 to 20, and since the 19.5 is somewhere in between the quartile class, then we say that the value that we get is correct.
For decile, first let me know what the decile is. Decile for group data are the values which divided whole distribution and equal parts. Since we have a FDT or frequency distribution table here, the given data same as on getting quartiles, and if you are asking how to get or where do we get the LB, which is the lower boundary. So 11 minus 0.5 equals 10.5. 16 minus 0.5 equals 15.5, and so on. And now, we find the value of P5 for deciles group data using the formula D is equal to LOC plus C, open parenthesis D, and over 10 minus FB, close parenthesis, over FBC. Then, substitute natin. D5 minus 25.5 plus 5, open parenthesis 5, 50 over 10, minus 23, close parenthesis over 15. Then, D5 minus 25.5 plus 5, open parenthesis 0.15, close parenthesis 3333. Then, D5 minus is equal to 26.16 or 26.17. Remember that your decile value should be somewhere in between your decile class.
And now we're going to discuss with you the process on how to get the value for percentiles for group data. So the formula that we're going to use in percentiles is n over 100. P equals L sub PC plus C, close and open parenthesis, P, close and open parenthesis, n over 100 minus F sub B all over F sub BC, wherein LPC is lower class boundary of the percentile class, C is per class size, FB is less than CFB for the percentile class, and N is the total number of observations. The table below represents the scores of 50 students in a chapter test. So we need to find the value of P22. So we're going to use the percentile formula for ungroup data, which is P, close and open parenthesis, N over 100, or 22, close and open parenthesis, 50 over 100 is equals to 11. So we need to find under cumulative frequency, or the smallest number that is equal to 11 or greater than 11, and that is 15. So P equals 15.5 plus 5, close and open parenthesis, 22, close and open parenthesis, 50 over 100 minus 3 all over 10. P22 equals 15.5 plus 5 times 0.8, that is equals to 19.5. So our answer is P22 equals 19.5. The percentile is equally divided to 100 equal parts. Each part is equivalent to 1%. Since we're finding the value of P22, that means 22% of the students got scores are equal or above 19.5, or 78% of the students got scores are equal or above 19.5. To check if the value of percentile is correct, since our percentile value is 19.5,